Okay, let's take a look at these two problems where we're graphing and we're also having to state what the transformations are. So these are quadratics. We know that because we see the little exponent of 2 in both of them. That's the greatest exponent. So those are quadratic. So I know that these are going to be like parabolas, you know, little U shapes, or they might be upside down. That's kind of pointy, but imagine a nice, happy little U-shaped function there. All right, so I know that's something like that. And so we'll start with the first one. When you see the parentheses and the squared like that, then this is in vertex form. And so we know the vertex is the opposite of the number in parentheses, so 4, and then the number at the end, which is -4. So notice what happens. The number in parentheses becomes the opposite sign, but the number at the end stays the same. Okay. So our vertex is at 4, -4. So I'm going to go right 4 and down 4 and put a point. And so now I have to think about, you know, whether it's opening up or down, how wide it is or narrow or just a regular U shape, that kind of thing. And so if you look right after the equal sign in front of the parentheses, there's nothing there. Technically, there's an understood 1, right? So if A is positive, which in this case it is, there's no negative in front, then I know it's going to open upward. And so you might be able to just sketch. That's terrible. A basic upward opening sort of graph. Let me show you a nice clean one. Let me take the other one off for a second. All right, there's super nice clean graph, right? Most likely you're going to actually need to figure out some values. So let's look at how we can find some actual values on the graph so that we're not just saying, okay, it opens up and just doing a U shape. If your teacher's okay with that, then that's of course fine. To find some actual values, let's find something on one side and then we can mirror it on the other side. So I'm gonna say, well, if the vertex is at 4, let's figure out what a value is at 3. So I'm going to take this equation, y equals x minus 4 squared minus 4, and I'm going to put in a 3 right there so that I can see when x is 3 what my y value is. Well, 3 minus 4 is -1. So this is y equals -1 squared minus 4. Now, if you're doing this on your calculator, be sure you're in charge of your calculator and tell it to square the whole thing. -1 times -1 is +1. And that is -3. 1 minus 4 is -3. So that just tells us that at 3, the graph will be at -3. That's a coordinate point because remember we replaced x with 3. So at 3, we're down at -3. And we just want to mirror it on the other side. And that helps us to see, you know, much better where our parabola is kind of going. So we'll just do something like this. Okay. Nice and as evenly as you can make it. So now stating the transformations. Well, the transformations are based on what's called a parent function, which would be y equals x squared. And think about a parent function at y equals x squared is just right here at the origin, and it's opening up something like this. Okay, generally. All right, but it's at 0, 0. So think about what's happened here. Well, we've moved to the right 4 and down 4. So that we can see straight from our vertex. So transformations, one is a translation right 4 units. We've also had a translation down 4 units. And then there's nothing else because from x squared to this, there's no other change. A equals 1. There's no negative in front. There's no larger number. We just have the right 4 and down 4. So these are the 2 transformations. Okay, let's go to number 3. Let's do the same thing. Let's get a different color. So if we do our vertex here, we know it's the opposite of the parentheses, so -6, and then the number at the end is 1. So for this one, we're going to go left 6, up 1. And really, you've just stated, or I just stated 2 of the transformations. I went left 6 and I went up 1. So that's kind of interesting. If you think about when you plot the vertex, you're stating, kind of what's happening there, at least for 2 of them. Now this will have more because we have something going on here in front of the parentheses and after the equal sign. Okay, so let's get a couple of more things. I see that there's a negative, so I know that it's going to open downward. Let's pretend that's more U-shaped, more curved. Okay. I know it opens downward, but it also has this 1/2, which is going to affect the shape of the parabola. So let's get a point. Let's go either way. We can go, let's go here. Now I don't need to put my actual point there because that's not where it is. But let's go to -5. So I'm going to plug into this. Y equals -1/2 times x plus 6 squared plus 1. And I'm going to put in -5 because it's near, on the x-axis, it's near our vertex. So -5. Okay. So I've got y equals -1/2 times 6 minus 5 is 1. 1 squared is just 1. So I'm multiplying by 1. -1/2 times 1 is -1/2. So 1 minus 1/2 is 1/2. So I get that when I go to -5, my y value is up 1/2. So at -5, it's up just barely. So I'll mirror it, do a reflective, just like have the same height on that side. And then it kind of helps me to see that this is going to be a little bit wider as it opens out. It still needs to be a U shape. You don't want it to be pointed. You don't want it to be a V shape because that's an absolute value function, but generally. So again, we're just sketching. All right. So as we look at this, we can see a couple of more things that happened. It's upside down. So I would say a third transformation is that it's a reflection over the x-axis. Right? And that actually comes from the negative. The negative after the equal sign tells us this is going to be a reflection. It's going to be flipped over. Reflect means flip. And it's across the x-axis. Instead of being upward, it opens downward. And then the fourth one, I'm out of room, but the fourth transformation has to do with that 1/2. 1/2 is less than 1, obviously, right? It's a fraction less than 1. And so when that happens, you have this wider graph. It is sort of shrinking down to the x-axis in a sense, like it's opening wider. If this number was greater than 1, like if it was 2 or 3 or 4, then the graph would get taller and it would be more narrow, and that's called a stretch. It's stretching it upward. This is shrinking it downward. So this is called a vertical shrink. Sometimes it's called a compression. So either word, vertical shrink, reflection, up 1, left 6. Those are the transformations from the parent function y equals x squared. Okay, that was a lot going on. 2 examples. I wanted to give you some good examples of some different things going on. And I hope that helps. Remember, don't let anyone think less of you because you're young. I'll see you next time.